Okay, well, I guess we should get started then. Welcome to the Preservation Tools, Techniques, and why is it doing that? Preservation Tools, Techniques, and Policies Interest Group. I'm Mike Hildreth, and along with Peter Cornwell and Ruth Dwyer, we're the three co-chairs of this. And yes, it looks like we have a small but intimate group here to discuss various things. We actually have quite a full agenda, but we're going to try to leave some time for discussion. Here's what we planned for you today. We'll have a few things on long-term preservation strategies. And I will let each of those people introduce what it is they're going to talk about. They're all sort of interrelated in some sense. We have a couple of things on data, and then the final topic is annotation, and so there'll be some presentations on that as well. So I don't want to take a lot of time on the introduction here because we have things to work through. But we're just to remind you of the sort of focus of this group, if you will. We're interested in tools for preservation directed at researchers, and so how one could make it easier for your average researcher to make their data reusable. I'll talk about FAIR later, but just in terms of being able to preserve what you're doing in an easy way or a less difficult way is probably the better way to phrase it. And so we're trying to sort of bridge the gap between people who are specialists in preservation and the people out there actually doing research and trying to figure out ways to get them to talk to each other and ways to give them tools to make their research more preservable. And then we have these, we've got some slides available for download at this website here, Data Futures. And there we have that collaborative notes document. I think there are 2 or 3 of them running around. There is a sign-in sheet. So if you are here and are interested in what we are doing, we ask you to sign in, put your name and email on there. We do actually have a mailing list for the group, which you could sign into. And so if you have interesting things to note, we have this notes document. And so I guess with that, I will stop here and then hand over to our first speaker, which should be Adam.
Yes, indeed. Thanks, Mike. Sharing my slides. Hi, everybody, and thanks especially to those joining us from a middle of the night time zone. My name's Adam Bell. I manage the outreach to the cultural institutions that are connected to AARNet, which is Australia's academic and research network. And I'll just take you through our vision for long-term preservation, some of the network and the services that we deliver, the tools and standards that we recognise that we will need to support, and some projects that we're participating in. So AARNet's vision is to support and accelerate the innovation within Australia's research and education sectors, which also includes cultural institutions. As a national resource, we are well placed to deliver a benefit to cultural organisations, the investments in research technologies that we are making. So we include within our GLAM organisations that are connected to AARNet some of the university and research organisation archives and collections as well. We are a national research and education network which interconnects with others across the world, and we also operate. Well, our main operation is the high-speed fibre optic network that connects organisations across Australia. On top of that network, we also deliver other services. Most notably for this discussion is CloudStore, which is based on CERN's EOS Object Store, which we operate in 4 sites around Australia. We not only deliver CloudStore as the own cloud-based sync and share application, which includes Jupyter notebooks. It is also available to institutions to use over an S3 gateway at this time to support their institutional file systems or preservation services. In the pipeline for us, expecting to have a tape archive based upon the CERN tape archive service. We expect that to be up and running during next year. We're implementing this for our own purposes. This is not an HSM or tiered storage service. It is an archive, and clearly tape is still the cheapest storage service that we can consider delivering. And there's a number of benefits there that, for instance, meaning that our mean recall time from the tape system being under a minute means it's a viable archive service that we could use for long-term preservation. But we also recognise that to deliver a digital preservation service, we need to do a bit more than simply just offering a storage system. Obviously, we need to support the FAIR principles, and we think that at this time, our main responsibility is around the A and the I in FAIR. So the preservation responsibility is something that we would share with the institution. We're not necessarily in the business of delivering the whole thing. This diagram here, which I've borrowed from the Archivematica documentation, describes some of the microservices and tools that are linked together to form the preservation workflow. So our job will be to ensure that our storage services are capable, in particular, in the fixity and data packaging aspect of the service. So if we consult the Digital Preservation Coalition's storage article in their handbook, we can see that there's a little bit more in there than simply offering a robust bit preservation service. One thing that is incredibly important is that we allow migration not only between storage services and technologies, but even between organizations. We do want to avoid the kind of service or vendor lock-in that might occur. Fixity is a key principle in preservation, and part of this is generating the checksums that may be stored alongside a file or the digital material, which is where data packaging comes in to play. Some of you may recognise this list of principles and the icon there, coming from the Oxford Common File layout, which is something that Neil will talk about a bit later on. But we recognise the data packaging as a crucial part of ensuring long-term preservation and access to material. The most commonly used data packaging format is Bagot, which is, we see, well, it's been proposed and developed by the Library of Congress, but it is widely used in the libraries and archives communities. We have a couple of projects that we're participating in, and we have worked with Preservica and Archivematica to ensure our services interoperate with theirs. We have one instance of Preservica operating on our services, that is at the University of Melbourne in Australia. Archivematica is an open source project that is well understood, and there's an increasing demand on us supporting or delivering this as a service. So we're intending to explore this in more detail in the coming year. The Archiver project, which is developed by CERN, is a project where I think it's about 5 organisations are developing tools and services for the European Open Science Cloud. So we're an observer and an early adopter on that project. And this chart is adapted from their requirements. And I've just edited that slightly to reflect our services. So the layers here that are expressed are a useful document to describe some of the services that we already offer, especially in the layer 1 and the layer 4 in this table. But that layer 2 preservation services, I think, clearly help us define what we really need to support and maybe even deliver to encourage long-term preservation and support organisations doing so. Another really interesting project that we're participating in is the Play It Again project, which is led by Professor Melanie Swalwell at Swinburne Uni in Melbourne. It's a major part of this project is emulation as a service infrastructure to support their preservation of video games and Australian media arts, which are complex digital objects and are relying upon obsolete applications and operating systems. There is also a broader application to emulation, of course, potentially within the reproducibility of results in science and humanities. And I'd like to notably mention the Archisto project, which has been motivated largely by Dr. Peter Sefton from the University of Technology in Sydney. This is a service that is built upon the Research Object Crate and the OCFL. And one thing that is particularly interesting here is that they've designed a service that relies upon commodity IT systems. So it can be reasonably easy to implement with existing IT resources and knowledge. We're watching this project with interest, especially in that a storage service will be required to accept data that is packaged in within the standards and specs that are described in this project. I'd also like just to draw to your attention the community of practice Australasia Preserves that is very active, it's very vibrant and very diverse in Australia. We support and participate in this community of practice, which includes participants and practitioners from across Australian institutions, including the major GLAMs and the universities and research organisations. And as of last year, we joined the Digital Preservation Coalition, which now has an office in Australia based at the Melbourne University. So we see this as being a very positive step within our locality to support the long-term preservation needs and responsibilities of the organisations that are connected to AARNet. And that concludes my very quick presentation.
Thank you. Are there any questions for Adam?
Could I just say thanks for filling in the sign-in sheet. There's another document, or you can just put it in the sign-in sheet. We were going to suggest that longer discussion, we should have 20 minutes left at the end. If you pick up any particular topics that you'd like us to revisit, please put them in that document and we'll have a look as we go.
Okay, thanks. I guess maybe once Lars is finished, we can kind of explore a little bit the sort of links between a lot of these strategies and what's going on at CERN. So maybe there's a series of questions there. So Lars, why don't you take over the next talk?
Okay, here, mute. Okay, yeah, so my name is Lars Holm Nielsen. I work at CERN and CERN IT at the Digital Repository section. And I'm gonna talk to you a little bit about Invenio RDM, and more specifically about how we are supporting domain-specific data in a generic repository. So Invenio RDM, if I have to explain it simply, it's a bit like install your own Zenodo. We have had 7 years of experience in building and running and operating Zenodo, and there's a significant amount of other institutions that was interested in running their own Zenodo clone. So we've booted up a project in making a platform, Invenio RDM, that is essentially like this: install your own Zenodo and a community behind it. And right now we're 18 partners from various different communities. So we have health and medical sciences, we have high energy physics, obviously, with CERN, we have social sciences, people from GEOs, institutions, national initiatives, international initiatives. So it's quite a good mix of different partners that are trying to use the same platform. And we all come together based on building a platform that's scalable and have a great user experience for our end users. So it's not a final product yet. It's still a product. We're still working on it. So here you just see some screenshots from the latest releases that are going out. What I'll mainly talk about today is like how are we actually enabling that all these different use cases that our different partners has and putting that into a generic infrastructure. So a case study or an example I like to bring is, for instance, taxonomic treatment, where we've done a lot of work with an organization called Platzi. So basically, these taxonomic treatments, they describe discoveries of new biological species, and surprisingly, they are communicated in journal articles, right? So you'll have 22 of these nice millipedes described in a journal article and published in a journal. And once you start looking into these taxonomic treatments, you'll see it's essentially data in disguises. So you have naming with identifiers, you have descriptions of it, you have material, like what is the actual physical specimens, right? And you have these images that are taken according to very specific scientific standards. And if we look a little bit closer for instance, on the material, then inside this journal article, you have nicely written up, for instance, where this physical specimen is stored. So here you have a collection code. So the Zoological Museum of Copenhagen is the ZMUC. You have geographical coordinates, collection dates, temporal metadata, right? And the collector, and there's a complete guide for how you're actually formatting all this. And if you just decide to stick this PDF inside a repository, then there's a lot of answers that is very hard to actually answer, right? There's things like how many species has been described by a given collection. You know, give me all the images of a specific species. Let me know everything you have about a geographical region of species. And when you're in a global pandemic, it might be useful to know which species are known host of SARS coronavirus 2, right? So all of these things is things we can't really answer because it's not properly extracted from these PDFs. And just to highlight the scale of the issue, then it's like the past 260 years of descriptions. It's almost about 10 million treatments are hidden up in this, and we're publishing about 17,000 new species a year. So there's a foreseeable amount of data here that's locked up in PDFs. So how can Invenio RDM, how do we try with Invenio RDM to make it more fair and more preservable? So it's not like rocket science what we're doing, but it works. So we have basically a common set of metadata based on data side. So we all agree on something like title, authors, and most importantly, persistent identifiers and anything, relations, spatial metadata, temporal metadata, and subjects. We have a shared commons, minimum shared common space where you can put a lot of it in, and that allows the data to be reused and understood by a lot of other services. Then on top of the common metadata, we're able in each of these Invenio RDM instances to basically add in any number of extra metadata fields. So you could take something like the collection code and get it from the David Core standard and get that into the metadata and make it searchable, so you can actually answer these questions that I highlighted before. Then in order to allow further exploration as well and describe it in even further detail, we allow also to basically associate any number of further metadata files. So if you had something very specific metadata, you can associate it with the file. So how does that look like when you put it into a repository? So you get a taxonomic treatment like this one. It's linked up. I haven't shown that here, but it's linked up with related identifiers. Everything is machine readable and can be exported in metadata, right? So you get all this biodiversity specific metadata stored together with the actual object and make it most importantly searchable. Okay. Then from the repository is just a key component in trying to store these things, a stable home for the record, but then it's not always the place where you actually discover these things. Then another example of how, so I've been talking about biodiversity, another example is these annotation collections we've added into Zenodo. That's a way that we're able to easily add new types of objects into the repository and accept it. So now I think Peter will talk a lot more about annotations, but here we're able to support the storage of long-term storage of an annotation, where Peter is then able to actually show make them searchable and integrated into the workflows of the researchers. So why do you put it into these things into a repository, right? In the end, you want it to go out. So for instance, here we have the Global Biodiversity Information Facility, who has is a big data aggregator. They're able, because we have extracted this information from the PDFs, they're able to now put dots on a map, make it searchable, integrated with all the images that was extracted and things like that. So I think one of my key messages here is it takes an ecosystem of different services. InvenioRDM is one component, and then one way that you can participate in this. Platzi is a small organization, highly specialized in text and data mining for extracting this information. You have data aggregators like GBIF. You need the registration services like DataSite, ORCID, things like that. So the InvenioRDM is just one part of this that allows you to participate in a big common infrastructure that actually works across many domains and allows you to do domain-specific, basically do a domain-specific solution with significant lower investment, because you're able to reuse a lot of all the existing stuff. And I think one of the most important things for repositories is, of course, that it's a stable home, so it must be resilient. And I will then leave it here for Neil, who's going to talk about OCFL, which is also a feature that we are implementing in InvenioRDM. Thank you.
Okay, thanks. Any questions for Lars? So is it possible to, can you go back to the slide where you were talking about what was searchable and what isn't?
Yeah. There we go.
Here's sort of a little layer cake diagram there.
Yeah. Yeah. So it's essentially the basic of a repository is you store a record, the metadata, and the files associated with it. And you might do full text indexing, but as soon as you start with research data, then full text indexing gets a bit complicated.
Yeah. Sure.
Right. So then a lot of it is about essentially like extract as much information about your data and put it in this metadata record. So you can, and if you get it into the metadata record, you can make it searchable via the usual search engines like Elasticsearch, right? Mm-hmm. Then the other part of it is that we have these associated files that we can add, where it might be that in order to use specific analysis tools or things like that, you need them in a specific format that we haven't implemented in the repository, right? And that's where it's useful sometimes to have associated files that simply stores this metadata. I think the important point here is that for a repository, you usually keep your file or keep strict control of the digital resource, but the metadata you can usually always update. And that's where we consider this domain-specific files as a metadata file that you can update if you learn more information about the data itself, but you're not actually messing with the
Okay. And so, yeah, okay, I'm not an archive expert, but I was just curious to understand that structure a little bit more. Thanks.
Yeah.
Any other questions for Lars?
Perhaps you say a couple more words about alternate storage layers. I mean, Venio natively is a kind of SQL. It assumes SQL, but there's been talk of other storage technologies, and you made reference to Neil.
Yeah, so I think the most important, right, is that as I say, a repository has to be a stable home, and that goes all the way through the entire application layer, all the way down to the hardware. And at the first level, you have a repository, the actual repository system itself, like in Venio RDM, which should be built in a way that's reasonable, resilient to business requirements. And that also means that the normal thing that happens to when you develop systems is they grow and grow and grow until they become unmaintainable, and then you cut them down, right? So we're architecting in Venio RDM in a way that we can cut off things. Then at the next layer, you need you have something at the way you store the files on disk, where there's OCFL, storing it with Backit inside it or similar, making sure that these associated metadata files that we actually have, they go into this OCFL structure. Right? So this is what we're doing with in Venio RDM. Today in Zenodo, we're only writing Backit in something that looks like OCFL, but it's not completely similar. But we're aligning with the standard. And then, of course, there's all the further hardware down the line, like CERN US with the disk storage systems. I think so. It's a big layered cake of things that can fail.
Great.
Okay, well, if we want to pick up on the theme of resilience, let's then move along to Neil and the OCFL stuff.
Hello, can you hear me? Right, this is OCFL has been mentioned a couple of times, so I'm going to explain sort of what it is and where it's at and what's going on around it. So it stands for the Oxford Common File Layout, and that is primarily because the initial meeting where it was first conceived was in Oxford, so it takes its name, as many initiatives do, from where the first meeting actually happened. There's a link to the website on the main slide. I'm the head of innovation for the Bodleian Libraries at the University of Oxford, or the digital scholarship side of things. I'm involved with repositories, digital preservation, digital forensics, a lot of bits and pieces like that. I have a background in physics, although mostly I'm a humanist nowadays. So what is the Oxford Common File Layout? It's an open community effort to try and define an application-independent way of storing versioned data in the form of complex digital objects for long-term access. What does that actually mean? And this is our logo, and the aim is really, when you've lost everything except for your storage, and you have that storage and you mount it, we would like to be able to recover as much as possible from just what is the structure on that storage device or server. So when the zombie apocalypse has come. So what is OCFL about? And I'm really going to talk about the considerations in the design, and then I'll go a little bit into what's going on underneath. So first of all, it aims to be for completeness, so that effectively, if you lose all of your repository software, everything that you need to rebuild that repository is actually in this OCFL structure on disk. So you can effectively rebuild that repository by installing a new instance of the software, mounting the OCFL structure and telling it to reindex. What that means is that data is stored close to its metadata in the structure. It falls in line with the general standards about preserving access to data, so things like OAS and things like that. And it allows ease of mapping from one system to another. So the aim of OCFL is not necessarily to rebuild the repository, using the same software that you used to create that structure on disk. So ideally, there is some level of portability between software. It is not a completely prescriptive standard, so that is not 100% the case, however. Parsability. So if you've lost the original software, a human should be able to look at the structure on disk or on storage, if they pulled it off tape or out of an object store, and they should be able to understand what the structure of the data is. So as much as possible, things are designed to be human readable and self-documenting, ideally. And what that also means is if you've lost the repository, it's actually very easy to place a web server or a simple access application on top of a storage system to be able to access your objects, even if you can't necessarily write to them, process transactions or things like that. So it's designed to be very, very easy to recover. Robustness, been mentioned several times, key part of preservation. So strong fixity is built in. Objects have an inventory, and in fact they have multiple copies of their inventory over their object lifetime, which contains strong fixity, and ideally objects are self-contained and can stand on their own. So an OCFL object is separate from the structure used to store it in storage, and the object can be moved into another OCFL type repository. An important thing, especially for digital objects, is versioning. It's very much in the nature of digital archives, unlike physical archives, for digital objects to change over time. OCFL allows that to be tracked. It supports forward delta at the file level, so that the amount of storage of data as objects go through is reduced. And the inventory.json includes a complete version history of the object. This is very important for citation purposes, so that if an object is referenced and you know when it was referenced, then you can effectively recover the state of that object at the time that it was referenced. Storage diversity. So it supports a conventional POSIX type file system metaphor in terms of a hierarchical data structure. But because we separate effectively a hierarchical structure that embodies an object with the way those objects are distributed throughout a storage system, there is no reason why it can't work quite happily with object stores, which have effectively a very flat type of structure, and conventional file systems. So what's the status of the project? First, the alpha release came out in October 2018. It's been through multiple releases, lots of community feedback, and version 1 came out in July 2020. And really, we're just refining effectively an extension mechanism at the moment, but the specification has been released and is standing. Release criteria, which we've all met, is that we should actually have a validator code for the specification, a test suite and a set of fixture objects, and 2 institutional commitments to actually develop software around that. We have met that very well in spades. So currently, it's a list of institutions there who are working on tools and code and libraries to operate on OCFL. On the next page, actual active development of repository systems around there, and you can see several there with links there. There's the Hasdai network from Data Futures, that's based on Invenio RDM, Lyrasis. The next version of Fedora repository will use OCFL, and there are several other links there that you can look at. So there's quite a lot of activity, and many of these actually started before we'd actually got to the version 1 released, which gave us a lot of useful feedback from the community, but also a lot of confidence that we were actually meeting a useful demand. So a set of links there. We have monthly calls, community calls, basically to give you an update on progress and what we've been up to, and also to demo work that other people have done. Everything takes place on GitHub. You can look in, and we are now in the process of collecting use cases and feedback to look at potential other iteration in terms of additional features. Ideally, this will develop in a way such that any future versions of OCFL will be compliant with previous versions, or certainly interoperate with them. And thank you very much. That's it from me.
Okay, thank you very much. Questions for Neil? So I'll toss one out there. So in terms of the again, I'm not an archivist, so but knowing almost nothing about this, what is the sort of scope for this sort of spreading widely across the landscape of archives? I have no idea the sort of paradigm shift. How that would actually work.
In a way, a large number of archival systems do something very similar. The versioning and the forward differencing is possibly a little different. A lot of archives have tended to assume that objects are static, which I don't think is necessarily a valid assumption any longer. But in terms of a file system type disposition and that sort of structure of objects, OCFL is quite closely aligned with bags and also RO crates, consequently. So it's very easy to map those into OCFL objects and vice versa. So there is quite a lot of movement in that general direction, and OCFL to some extent formalizes that in a common approach across multiple systems. The ultimate aim is really, when you change systems, when your software becomes obsolete, to largely avoid the need to have to migrate all of those objects into the new system, but rather simply to mount them underneath whatever your new system is, and to then do some updating of the objects in situ. So a lot of the design, for example, allows you, there are existing standards. Stanford has something called MOAB, and the idea is you could bring a MOAB type object into OCFL, and the way you make it OCFL compliant is simply to add a new updated version on top of the existing version tree. So the idea there is actually object movement is generally when loss is most likely to occur. When stuff's in storage, it tends to be pretty safe. It's when it's moving around on networks and going through curators and archivists' desktops that you tend to be at highest risk, simply because a lot of those aren't workstation grade machines. So I think it does have the potential to become quite widespread, and we've seen people picking it up left all over the place simply because it defines something that they were probably going to do something similar to anyway, and it gives them a standardized way of approaching that.
Great, thanks. Other comments and questions for Neil? Okay, I think that means I'm next. I did manage to find a Costa Rica background. Let's see, where is this? Can you see the slides?
Oh, yes.
Okay, good, thank you. All right, great. This will be rather short. This is more of a public service announcement, because I personally have not been doing much in the way of FAIR activities over the past, why is it doing that? Past few months here. So in any case, since Natalie is here, we led what was probably one of the earliest FAIR workshops in the US. So I'm going to focus on the US because FAIR seems to be spreading like wildfire across Europe and maybe the rest of the globe, but it's been a little slow here in the States. So we led this mathematical and physical sciences FAIR hackathon. Hard to believe it was almost 18 months ago at this point. But since then, there actually has been a fair amount of traction. This next alphabetic soup meeting here, the important 3 letters here, the National Academy of Sciences, this workshop on FAIR data. So there is high level attention being paid to the concepts of FAIR and how they fit into science across the US. We have the USGS, NIH, NIST. I think I'm somewhat disappointed that we haven't seen more action out of the National Science Foundation and the Department of Energy, since they are the largest sponsors of physical sciences in the US. So they've been sort of involved behind the scenes, not DOE actually for the most part, but NSF has been. So anyway, things are ramping up and being supported at a rather high level, although I'll sort of give my read on that in a minute. So it's nice to see is now we have our own GoFair instance in the US. Their website went live in July. They've hosted a workshop, some webinar series, some train the trainer events. And we even have implementation networks, FAIR implementation networks creeping into the US. And so those are people working on similar topics, trying to understand how to make them fair. And so it's nice to see this movement. I want to talk about tools because that is sort of the topic of our group. And yeah, I apologize if I'm leaving out a bunch of stuff in this talk. This is just sort of meant to be a snapshot. And so if you have other examples, this is why we have the notes document. Please put examples in the notes document that you want us to look at. But I think most of the tools that have been developed right now are mostly for verifying fairness, because that's relatively easy compared to making your data fair and developing tools for making your data fair. And I think, you know, as we've talked about in this session before, that really has to sort of come from the domains. But and it did actually get attention in the National Academy's workshop, but I think that's the area that's most ripe for development in some sense. But there are all these tools that allow you to look at your data and figure out different ways, maybe to verify it, or then to check and see if it's fair. There's one on the list here. Again, thanks Natalie for the input here. There's a verification tool for nano safety data. So you can look at that link and see how that works. I believe it takes an Excel spreadsheet as an input. So not exactly the most sophisticated data type, but it's a step in the right direction. And then sort of finally, I wanted to make a sort of big picture comment. I've spent a bunch of time on various advisory panels for efforts in machine learning and artificial intelligence over the past year or so. And it sort of, this shouldn't have been a surprise, but for those of you who haven't thought about this, what you need for machine learning is labeled understandable data sets. And so the FAIR data and vast quantities of FAIR data are going to be absolutely crucial if science or industry more broadly is going to be able to use it for machine learning and AI. So maybe this is obvious to people, but I hadn't thought about it before. So I thought I would mention it because it was in another set of workshops about a week ago and people hadn't even heard of FAIR and we were talking about machine learning. So I'll just put it out there. If you want to have vast quantities of data to train your machine learning algorithm, it has to be labeled and you have to know what it is. And so there's a premium on FAIR data sets. And I think once you say that, then there's a recognition that you have to provide tools to prepare these data sets or else no one's going to do it. But the good news is that there's an actual economic incentive to drive the adoption of FAIR and the development of these tools. So one of the pillars of the Go FAIR movement is go build. And so I'm hoping that people will go build and come up with these tools so that we can push the adoption of FAIR and the general preservation of everything moving forward. But it's clear that these data sets are not going to just create themselves. And so now that there's an economic incentive, there's probably going to be an economic incentive to develop some nice tools, workflow capture, automatic metadata capture, et cetera, and frameworks to do this. So that's the good news. So that's my small little soapbox speech. And I will stop there and pass things on to, well, see if there are any questions, and then pass things on to Ruth next. So I'm happy to take questions and comments. Okay, well, if not, Ruth, you're up.
Of course, it would help if I unmute. Do you see the slides? And can you hear me?
Yes, yes, and yes.
Okay, great. So I'm going to talk briefly about something I talked about, I think 2 years ago here, which is a little program, a volunteer nonprofit that's kind of still emerging, called basically the at-risk data commons. And you basically see the team of people who've been working on this. My name's only first, simply because I'm giving this talk. Okay. And what the at-risk data commons is a website and an associated nonprofit organization. And our goals are to connect people who have data at risk or who know about data at risk to volunteers, data experts, and additional resources. And this is our vision. We're not totally there yet, but it is a match.com for basically data at risk and orphaned or surrendered data. It's not intended to be an archive. It may possibly foster data on its way to an archive, but that's what it does. And as I mentioned a little bit earlier, it's got really two components, an organization and some tooling. And I guess we'll talk about the tools first. It's basically a website that allows you to basically nominate tools or nominate data that you think needs to be rescued. And basically it's a web form, and it allows anonymity. If you need to be like a whistleblower, that has become a much more obvious need over the last few years. And it enables people to, and I'm including citizens here who have some skills in some way, to sign up and work on activities that meet their interests and capabilities. And the reason why I can do that is it is mediating between what the nominator thinks needs to be done and a list of tasks of doable items that can be done by using what we call data advocates. And so that basically leads to the idea that we have kinds of participation, and there are basically three kinds. Submitters, people who actually can submit a data rescue request. Yes, they can be anonymous, so they need to have an email, but we'll give them hints as to how to do that anonymously as well. Data advocates are the facilitators who connect those submitted requests and create the tasks that data heroes can do to help move data from being at risk to having a more secure state. And so here's sort of the way that process works. That you have a submitter submitting a request saying, hi, this data needs to be rescued because the server is going to die and we don't have funding to replace it, or whatever the case may be. It may be that we have, you know, analog data that needs to be digitized and put online or whatever. It goes in as a request. Advocates assess and sort and split that request up into all the various subtasks that may need to be done. That can be a wide variety of tasks, and a single request coming in might turn into 20 or 30 tasks that need to be done to rescue that data. And those tasks then are basically put on a list that volunteers, heroes, can look at and go, oh, I know how to do that, and select one and go and do it. And then obviously advocates need to check the results of that. And if it looks good, go ahead when all the tasks are done and send that off to the submitter, who then basically checks off that, yep, great, this data has been rescued. And we do have, and most of the technology part of this is in the two areas that have prototypes implemented: the request submission forms and the task lists, which is really pretty similar to a ticketing system. Basically, actually, it is a ticketing system that allows people to come in and pick things off the list and work on them. And I should note that the whole reason why this project is ongoing, though it is very slow, is because it's being all done by volunteers. But the implementation and hosting of the system is done by a corporation here in the United States called Cloudburst Inc., whose Chief Data Officer, Joan Saez, basically has a passion for not losing data, and so has been basically funding most of the work on a, you know, as time and resources permit kind of basis. Now, also in the United States, NSF has funded something called a Science Gateways Community Institute, which supports the development of tools and what they call gateways for the science or research community. And so we took advantage of that service and have done things like they have a boot camp for how to create corporations and all the things you need to think about when you're building a system or service like this. And they also have technical support, and we took advantage of that as well. And there are security and user interface experience work that we're taking advantage with them also here in the near future. And then they also not just provide technical development support, but they provide business development support. And so we're using their services there in the areas of sustainability, onboarding, and volunteer management. We're a totally open group. We have weekly team meetings, though there are two different teams and they actually meet on alternate weeks. So there's a technical meeting on alternate Wednesdays and a business operations meeting on alternate Mondays. And anybody is welcome to attend. There is contact information on a slide down the road just a bit. All the development we're doing is based on use cases. And the first one is actually made up, but it's made up based on actual experience several of the people contributing to this project have had in the past, so it's pretty realistic. And so you can, I'm not going to talk about the use cases in details, but there's lots of them. And they range from everything from you know, large agencies who have basically bit preservation from 50 years ago that needs to be migrated forward, to researchers who have no clue where to put their data. So I said that we had technical support. I'm not really going to go through this, basically just saying that, you know, we've had a lot of good technical support from the SGCI process. So if you're in the United States and you have the opportunity, I think you should use that service. And they've even done things like help us with text and stuff like that. Do I need superpowers to be a data hero? No. Anyway, and similarly, we have been developing a sustainability model onboarding processes for all the various types of members and a volunteer management plan. So we've actually made a huge amount of progress over the last year, I would say, despite COVID. And just as sort of a teaser, I note that we actually have thought through value propositions for various communities. And that includes repositories, data librarians, educators, researchers, as well as data heroes and members of the organization itself. And so data@risk.org is the website. You can use the contact us button, or actually you could put a note in our notes document here today saying, hi, you want to participate. If you want to actively participate, you could join the Google group data nomination tool, but that would basically get you kind of into the notice of all the meetings and decision-making processes and such. So that's active participation. But if you just want to keep in touch, you know, occasionally, we are working on establishing a newsletter that we'll hope to get out, you know, if at most updated a couple of times a year. And if you're interested and or want to have a further discussion, you could email me. And that's sort of my email, which hopefully isn't that easily parsed. So as for where we're really at, the nomination form is up and active, though we do not really have the task and advocate situation completed yet. The software side of that is undergoing testing at this point, but we have a lot of work to do to one, finalize becoming a nonprofit in the United States, which actually takes more time than you'd think. And getting together all the training materials and operations procedures and all of that kind of stuff. So that's where we're at. That's the update. And if anybody has questions, now would be a good time.
Did you say how many data sets you've rescued?
I did not, because I also just ended by saying that we're not really in operation yet. I will say that the list we have is long. And actually, we have started rescuing data sets at a really slow rate, in that this started because of the class I was teaching at UIUC, where we rescued a few of those NASA data sets, and got its furtherance because Joan did the data rescue Boulder, where she basically cloned all of the EPA data sets that were in existence. And I do mean really cloned. She was not interested in a website. She was interested in copying servers full of data. So I wouldn't say we're in operation yet, but expect to be, actually, I'm feeling very optimistic that we might actually be really in operation within the next 6 months or so.
Cool.
But again, it'll be at a low rate.
Other questions for Ruth?
Very quiet group today.
I know.
Scary.
So if not, I think we'll turn things over to Peter and Eric, and you can move things along.
Thank you, Mike. So my name is Peter Cornwell. I'm part of Data Futures, and I've also got a post at ENS in Lyon. PTTP has been involved in preserving scientific annotation. It has a nascent working group. And in the last year, we've run a couple of webinars. We did one jointly with the engineering folks, research data management for engineers, and subsequently, more recently with the Frankfurt Book Fair, we've run a number of pilot projects, and this particular thing has resulted in the entire back and current catalogue of a German publisher becoming open access. And these seem to attract fairly good audience, both from the Frankfurt Book Fair itself and from RDA. What I'm going to talk about tonight, and I'm going to pass off to Eric in a minute, is another project that was originally part of a pilot, which, because of the COVID situation in the spring, turned into an active production project. And basically what we did was to upgrade annotation infrastructure at a number of institutions, and built a collaboration within about a month, and it was in operation during the spring. And in point of fact, some of these projects are still actually running. So primarily it involved Basel in Switzerland, ENS in France, and Notre Dame in the US. The annotation infrastructure that was already in place didn't really support secure authentication, and we used CERN's OAuth and ORCID sign-in so that we could support a whole variety of staff and students and temporary contract people that were no longer on site, and this basically unified a distributed workforce with ongoing research. So here's a couple of slides from Notre Dame. Don Brower actually managed and coordinated a lot of this. This also plugged into the HASDAI network of Invenio repositories that has been mentioned earlier. But Don ran this from the Hesper Library at Notre Dame. The main additions, as I said, were really to authenticate contributions. We needed for there to be a simple way to get people to be able to work on these tasks. But at the same time, we didn't want potentially secure resources to be available to the public. And of course, we didn't want people to be able to write all over annotations that had been developed at some cost. But what this achieved was effectively a cost-neutral exercise in which these three organizations contributed resource either in management, existing research tasks, or staff that were unable to come to work at the campus. This is an example of one of the work information sheets, and you can see there's a number of tasks on the left. There's links which were effectively, in many cases, were Google Docs. It gave simple instructions. It was one point of access to this entire service, but a number of different tasks from different organizations were layered on this from time to time, and in point of fact, some of them are still running. So down the bottom, this Vietnam information thing is from France. Epistemological letters was actually a native Notre Dame thing. And the Asian Directories and Chronicles is an ongoing project, but that has already completed several thousand annotations for the group in Basel. So really what this did was manage and reduce training needs so that people didn't need to attend classes. All the information was provided through the shared documents. John Brower organized a help desk, and on logging in, people got access to this Invenio-based authentication, and simply with their ORCID, they could choose to work on one or other of these tasks. And what this program produced was thousands of annotations, but these were subsequently processed into WADM, Web Annotation Data Model, annotation collections. And Lars had mentioned earlier that there is a Zenodo facility to actually create Zenodo records as annotation collections. There's an example here for a project that had been run in Basel 3 or 4 months before, but these projects also led to completely new Invenio repositories, in particular for the Vietnam information. And Eric's going to talk in a minute about this Asian Directories and Chronicles Treaties project. So those are addresses of actual Invenio repositories, which you can go visit, and they've been constructed entirely from the annotations as primary research assets developed during these tasks. So there's the annotation collection marker in Zenodo. And in particular, this is 50 and 60 megabytes of JSON as annotation collection. And those annotations can be consumed by a whole variety of different external applications such as GIS. And here's an example of the Vietnam information repository that was generated from this, which is now possible to access via Elasticsearch. And all of this has been created automatically from the annotations done by the folks in France and in mainly the US. So if I could hand off here to Eric to talk in more detail about that Asian Directory Treaties project, it would probably put more detail around what actually transpired.
Hi, can you see the slides and hear me well?
Yes, totally.
Yes, okay. My name is Eric Decker. I'm working for University of Basel. I'd like to introduce you to the East Asian Treaties Annotation task. The aim of the East Asian Treaties Annotation task is to build a database of all international treaties, regulations, and legal documents that have been printed in the chronicling directory for China, Japan, the Philippines, and other countries between 1863 and 1941. I'd like to show you how we build and organize these annotation tasks, how we refine and enrich the data that comes out of the annotation tasks, and finally, how these annotation data sets get published and preserved in the Invenio-based TASLA repository. So our starting point for this endeavor is a corpus of about 70 annual publications with 250 to 2,500 pages each. So that leads us to a collection of more than 100,000 page impressions that we have to go through. And within that collection, we are especially interested in the treatise codes section of these books. And from these sections, we want to know the names of the treaties and how often they have been reprinted, and in the following years. And since each treaty has a title, we are concentrating mainly on finding the titles and annotating them. So, but before we start annotating, we put aside all the pages that do not belong to the treaty sections of the books. And then we stick the reduced set of pages in a customized mirrored or annotation workflow. And at that point, we hand the material over to the team at Notre Dame that Don Brower leads. And their task is to annotate treaty titles. That is basically draw a box around something that has been identified as a title. In the Google Sheets, we had a definition of what we think is a title of one of these of such an international treaty. Then they have to click the OCR button, correct the text that they get back, and save the annotation. So during the pilot phase of this project, we found nearly 2,500 headings, and these were turned into annotation assets. Each annotation asset stands for a heading, for the heading of one printed instance of a treaty. So that means when a certain treaty has been printed in, let's say, 30 books, we have, of course, 30 annotation assets, each of them with a transcription of the title that has been used in the respective book. So did we find 30 identical titles then? No. Throughout the years, the printed title for one and the same treaty can change, and that is often the case, and the changes are also significant. And that is, of course, a problem when you want to create a consistent database. So what can we do to address that problem? So fortunately, our annotation assets have a standardized structure. Each of them has a unique asset identifier. It comes with a transcription of the title, the IIIF fragment showing the exact part of the page where the title is printed. And we are using ORCID for annotator authentication and identification. So this data structure allows us to build applications to process and analyze the data further. In this case, we built a data normalization app to speed up the normalization process. That application uses the sequence matcher algorithm to find similar title variations. So with this interface you see here on the right-hand side of the slide, subject experts in Basel can then cluster variations of these titles and decide which of the variations should be used as standard title. So the result of this process are sort of bundles of title variations representing the same treaty. In the next step, we added metadata to these bundle up document titles. For example, we predicted the document type with a dictionary based approach, then did a manual validation of the predictions and added that information to our normalized data sets. The result can be seen here. So that as a result, we were able to automatically generate an in-venue-based repository of the pilot phase results that contains nearly 2,500 instances of documents that are now mapped to less than 400 canonical documents. This is a detail how it looks in the in-venue repository. On the right-hand side here, you see the normalized names of the treaties. You get additional information that you can filter, for example, all the treaty parties. You get the type of document that we have. You get the date of signature of the document, and you, of course, get the dates in which books they have been published. Just to give a quick summary before we end. So we started with that large corpus of more than 100,000 pages. We extracted the relevant pages, namely the treaty sections, handed that over to the team at Notre Dame, where the headers were annotated. These annotations were then normalized, and we added additional metadata to enrich the data and add value. And in the end, we generated that in-venue repository. So the key technologies used in that project were AAAF using a customized form of Mirador. We're using ORCID, the Hastai network of in-menu repositories, and ANOStore that was already mentioned earlier. So the institutions that were involved in that project is Basel University, Data Futures, and the team at Notre Dame University. And that's it from my side. Thank you very much. And I think we can hand over to the discussion now.
Brilliant, thanks. Can I just say that to clarify, that set of outputs was from the spring, wasn't it? So the actual application is still ongoing, and there's been probably twice as much generated.
Yes. So that was only the pilot phase I was discussing. So it's still ongoing. But
it's probably worth pointing out that the soup to nuts work from that annotation, the collection of annotation tasks, to production of the first version of the repository is probably only a couple of months. So it was possible to produce some valuable new data resources out of that shared work. Brilliant. Mike, can we hand back to you?
Yeah, sure. I was just going to ask. So the annotation was all done by people, right?
Yes. Yes.
Yeah. So each of the tasks in Don Brauer's sheet had a largely fugitive group of contributors. So people came and went. There was often 15 or 20 people. The treatise project was, well, still is probably one of the largest, but a lot of annotators working in France produced the Vietnam information corpus, and similarly the Scanlan maps and the other stuff at Notre Dame are, I guess, still ongoing.
And we decided to do it manually because the layer is rather inconsistent. So at the moment, there's not much of the layer to be exploited for an automation or something like that. Mm-hmm. So with that exercise, we're starting to build up this variation dictionaries, and maybe in the future we can use these for a more automatic approach.
In contrast, the other project that I showed that had the GIS output, the plot on a map, that's a much larger number of annotations, hundreds of thousands, and those were done automatically by a program actually reading the XML out of the OCR.
Mm-hmm. Any other questions for these two gentlemen? Does anyone else wants to throw into the session? Things you want to talk about? Well, it's probably very late for most of the people who have signed on here.
I think drawing together a couple of the strands there, one of the useful things about annotation is its use really as a transport between distributed workers, whether they're human or software, as distinct from the source material, which is one of the bits behind effectively the IIIF design. But API access to data immediately opens up the opportunity of using machine analytics to actually start extracting the metadata, getting back to Lars' point. Mm-hmm. But you can also envisage iterative approaches where you have machine processing of data sets which generate a set of annotations which are then corrected by people, which are then used as an updated training set for the algorithm. And iterating that through several cycles to effectively tune the algorithm and remove systemic biases as your data set grows.
Mm-hmm.
So Marjolaine, I'm probably pronouncing that totally badly, has a question in the chat about, you know, as a research team looking into opening up and starting using FAIR guidelines along with open sharing of data sets, complete beginners, where would you suggest to start? Platform, information, training, seeking, general tools, etc. This is my opinion. I think finding out what's out there is the first place to start. In other words, you need to seek some of that training. I note that a group in the Federation of Earth Science Information Partners in the United States is actually working on a document to provide just exactly those answers, kind of, but they're nowhere near done yet. But beyond training, if you're in a particular discipline, if there are disciplinary standards for data formats and metadata, I would try and find out what those are and then follow them. That's a good first step. If there's repositories that are commonly used by your community, go talk to the repositories because they'll have data managers who maybe it's their job to help you. And Natalie just put a post into the chat about training materials. The Data Management Training Clearinghouse, which is another ESIP project, has a lot of training materials related to FAIR data and how to be a good data person in general.
And also the Go FAIR people are running training workshops.
Yep.
The training of the trainers as well. So the US Go FAIR would be a good place to start too.
Yep.
Or not, well, if you're not in the US, Go FAIR in general, I think.
Yeah, true.
Everybody's fair these days. I think there are at least half a dozen new RDA working groups, or not even that new RDA working groups with FAIR in the title. There was a FAIR software meeting earlier today. That's more in the research stage, but anyway, so there's a lot of activity here, which is great.
Yeah, and if you're interested in metadata standards and policies, then there's fairsharing.org as well.
Right. Anything else people want to? Oh, Natalie has her hand up. Wow.
Yeah, I just wanted to share, I've pasted to the chat a link to the CoData Go FAIR International FAIR Convergence Symposium. That would be a great resource for people who want to dive in the deep end of the pool. And the Carpentry's top 10 FAIR data things are a great way to get in the shallow end of the pool. So between those two ends of the spectrum, there's a lot of ways to learn what you need to for the kind of projects you might have.
And then once you learn that, convince people to build tools.
Yep. The other place I would point you to is certainly in the UK's Digital Curation Centre, the DCC.
Mm-hmm.
They have a lot of stuff on research data management and all of the associated things, including FAIR.
So I'm planning on cleaning up these links because there's a lot of good links that just got dumped into the chat. So saving that and putting them in our notes document so that people can get back to that after the event.
Great, thanks, Ruth.
Okay.
Well, we're 2 minutes early.
Or later, the case may be.
So what would this community like to see this group do more of, or in the next months till the next? Are there particular topics you'd like discussed or anything like that in the community?
Ruth?
Yeah.
For preservation tools at the PresQT project, we're embarking on a QA phase where we are inviting about 500 people to do QA on our tool set. I would be interested in having members of the Preservation Tools, Techniques, and Policies interest group participate in that QA if they're interested, or to perhaps give a webinar or an online demo to the group in the weeks to come. The tool suite has preservation checking and fixity checking for digital objects on platforms as varied as GitLab, GitHub, Zenodo, and Open Science Framework, as well as ways to move files between those systems, run FAIR tests against them, and enhance their keywords. We're just opening the tool for testing, and more input is good input. So I hope everyone would join us in testing that tool suite and letting us know what tools make sense for you as researchers and in your domain.
There's a link to that in my talk. We could just send it out to our mailing list. No problem.
Yeah.
Anything else?
There's a contact mail on the RDA site, the PTTP. So please do send us further thoughts that come up. We'll endeavor to respond promptly.
Yes, thanks a lot, everybody. And have a good evening or early morning, as the case may be. Take care.
Good night.
Thanks to
Thanks,
all
everyone.
of you. Appreciate
you.
it.
Thanks, everyone.
Bye.
Bye.
Bye.